Exactly is Fleet. Fleet allows you to basically have an entire cluster of CoreOS servers, and it allows you to present that cluster as a single init system. So you can schedule deployments of units across your cluster. You can deploy containers on arbitrary hosts or specific hosts. You can distribute services as ephemeral units across all of those machines. And you can also tell it to maintain a set number of instances that you designate using Fleet and reschedule on failure. So that's very powerful. You also can control Fleet using a command line utility and accessing it over HTTP using Fleet-CTL, using an API. So you can do simple things like list the machines, list units. You can destroy units. You can launch unit files and actually deploy your application using unit files, which is actually what this is. So this is an example unit file of one of the services that Michael's going to kind of go into more detail later. But it allows you to specify some specific rules and configurations for when that service starts. So these are some of I guess, the more important configurations that we're going to be using for the demo. These are basically things that we've used to kind of control the deployment, right, of our NGINX deploy. So conflict tells Fleet basically not to schedule more than one unit on the same machine. Environment file allows you to import an actual environment variable from a specified file. We're going to use that. Execute start is obviously that. It basically, when the container starts, it executes, or when the service starts, it executes this specific command. Machine of tells Fleet to schedule the unit on the same server that you specify. So that allows you to do what we're doing with the Sidekick service discovery, where we're actually deploying the container and the service on the same host. You can also bind two units together. So basically, they will stop at the same time. So if this one fails, immediately kill this other unit. Execute stop is exactly that. You can tell it to, when this unit finishes getting deployed, or at the stop of when you actually stop the unit, execute this command. And then after, basically, it tells Fleet to schedule deployment after another unit. So you can tell it to do it in order. So deploy this one, then after, deploy this unit. etcd. So if you guys aren't familiar with etcd, etcd is really awesome. It's basically a key value storage that you can set up and distribute on your CoreOS cluster. So in this instance, we have, in this diagram, there's 5 different CoreOS clusters. All of them have etcd running on them, and all of them are constantly keeping in sync. It's written in Go, so it's very fast. And it also has a very simple interface that you can access over HTTP, or you can access it over a etcd-CTL, which is like a command line binary. It's secure, so you can do like SSL client certificate authentication for it as well. And like I said before, it's very fast. It's been tested using thousands of changes per second and doesn't have any problems. So this is basically an idea of what you would look at if you're using etcd-CTL to access the database, or just to get a list of the keys that are listed in that database. He's going to go more into detail exactly how we use Fleet and etcd together to do our deployment. But cool thing is, it's also available over HTTP. So there's a REST API. So anything you want to do, you can kind of choose to use either the binary, or you can use the REST API. So there we go. So lastly, NGINX. So why do we choose NGINX? Why do we like NGINX, other than the fact that I work for them? NGINX is a pretty awesome software load balancer. It allows you to deploy a lightweight software load balancer inside of a container and manage your containers from a load balancer's perspective. In this demo that we're doing, there's a couple different methods of how you could accomplish what we're going to do in the Sidekick service discovery method or model that we're using. First method would be is if you're using open source, you could use something like confd. If you guys aren't familiar with confd, confd is basically like a lightweight configuration management tool that allows you to access a data store like etcd and basically constantly check for changes and update a template file, like a template configuration file. So with method 1, you could actually manage that configuration file using confd, and you can even tell when there's a change to reload the application and pick up those config changes. So with open source, this can be accomplished. Although with our method today and what we're going to be doing in the demo, we're actually going to be using our dynamic reconfiguration API. This is a really simple HTTP API that allows you to manage the upstream servers all over HTTP. You can do things like add, remove, markup, mark down, adjust weights. And the key thing about this is it doesn't actually restart NGINX. So all these changes are actually made in memory and are reflected without the need to restart the services. If you have NGINX running and you're receiving a lot of traffic and you do a restart of or reload of the configuration, as we call it, it will spin up multiple worker processes and multiple, basically double the amount of worker processes on your machine. So if you're already receiving a lot of traffic and you're pushing that software load balancer, you can actually basically increase the memory and the CPU footprint on that box and maybe cause issues. Using the API, you don't have that issue. Also, application health checks. So another feature why we choose NGINX Plus for the demo is you can actually set a health check. So with this health check here, Michael's going to go over it in more detail, but it's basically just checking health every second to make sure that container is healthy. What about open source with health check? So there is health checking in NGINX open source, but it's a passive health check. Really, it just basically is constantly checking to see if that server is healthy. If it's not healthy, it will mark it down for a default of 10 seconds and then kind of recycle and try to check again constantly. So there's a little bit of latency with health checking with the open source product. So with that being said, we're going to do a live demo. This is Michael. Michael's an engineer working for us. And I got to give you this.
OK. So I'm logged in into one of the machines of my CoreOS cluster. And if I run fleetctl list machines, we'll see that I have 4 machines in my cluster. And I'm running this cluster locally with Vagrant. So first, let me show you the Unix files that we used for our services. So I'm going to start with a backend service. And let's see. So nothing really exciting here, except that when the unit starts, it launches NGINX hello container, which basically is NGINX configured to return the server IP address and host name as a web page. And it maps the port 8080 on the host machine to port 80 on the container. Another thing that we tell Fleet not to schedule more than 1 backend services on one machine. So the next service, the next unit file is backend discovery service. So here it's more interesting, and with combination of binds to, after, and machine of option, we tell Fleet to first of all schedule the backend discovery unit on the same unit as the corresponding backend, and also tell him to bind to the backend unit. So basically, when the backend stops, this discovery unit also stops. So there's exec start launches the inline shell script, and this script every 30 seconds it sets etcd key with IP address and port IP address of the machine at port 8080, which our backend use. And we do it every 30 seconds, but we also specify TTL option equals 40 seconds. And when the unit stops, it removes the key from etcd, basically, and registers the backend. OK, so let's launch our backends, and we're gonna use the script that I prepared. It's create.sh. Basically, it's gonna using Fleet CTL. It's gonna launch three backend units and 3 backend discovery units. OK, so let's see it in action. So it's gonna take probably 10 seconds, and we see that units are launched. And after that, we will check etcd. We will check if keys are indeed present there. So units, one more second, 2 more seconds. OK, they launched. OK, let's check etcd. So using etcd-ctl command, we will check if there are any keys in the services backend directory. So there's one, only one right now. So let's, using fleetctl, running. So basically, now everything is running. So let's check etcd again. So the problem was that the Docker images were pulling from Docker Hub. OK, so our backend services are up. So let's set up load balancing for them. OK, so let me show you the unit file for our load balancer. So when it starts, I launch load balancer from the NGINX plus CoreOS image. And we cannot put it on Docker Hub because the image contains license keys. So we just built it and made it available to every machine on the cluster. And we map ports from the container to the host machine. And we also tell Fleet not to schedule more than one load balancer unit on the same host and not to schedule it on the host where the backend service is already running. Let's see the interesting unit file, the discovery, load balancer discovery unit. Yeah. So as you can see, this has a lot of inline scripts, and I'm going to show you them later. But the main point, again, the same. We're using binds after and conflicts option. We start this unit on the same unit as a load balancer, and we link it together so that when the load balancer unit stops, this unit also stops. So the first thing is exec start pre option. So this launches the inline script, which you can see here, and it just get the values from etcd for the backends and add the corresponding backends to NGINX via upstream conf NPI Kevin told you about. Okay, so the next next command starts right after this one, and the command is etcd-ctl exec watch. So we watch the etcd directory services backend for any changes. And once the change happens, we launch the inline shell script, which I'm going to show you here. And these scripts doing the following. When the etcd key was added to etcd, we catch the set action, and we're adding the corresponding backend to NGINX. When the key was removed or expired, we removing the corresponding server from NGINX via API again. So let's see the configuration file for our NGINX. And here we have one server that is on port 80. And if we hit the location, the root location, we're going to be proxy passed into the upstream and the upstream backend. And as you can see, there is no servers added here because we're going to use API to add them. And the second server that we define listen on port 8081. And here we expose our status API, which I'm going to show you in a bit, and an upstream conf API, through which we're going to add servers. So note about the special named location health checks. So here we set up with the directive health check, active health checks of our backends. So every 1 second, NGINX will set a, by default, request to the upstream and expects 200 response code. And we set timeout values to 1 second here because default timeout values is like around 60 seconds. So we're going to use different values than the values that are for the root location. Okay, so let's start the load balancing unit. fleetctl start load balancer. And let's start load balancer discovery unit. Fleetctl start load balancer discovery. What we see is that it gets scheduled on the machine with this IP address. So we'll hit this machine. Oh, I did something wrong. OK, so we had our backend. And as you can see, I'm constantly refreshing it. And NGINX round-robin distributes requests among our backends. Now let me show you our dashboard. So here we can see that our NGINX has 3 servers that were added. So now what we do, let's remove one of the servers. Let's stop one of the backends. So we're going to do list units, and let's stop the backend that runs on the 4th machine. So it's the backend number 2. So fleetctl destroy, which we're going to destroy it, backend 2, and we're going to destroy service discovery for the unit for that backend. Destroy backend discovery. OK, so as you can see, that backend was unregistered from NGINX very quickly. And what we're going to do now is we're going to suspend one of the machines simulating outage. So it's going to be machine number, let's choose the victim, machine number 3. So we're going to use vagrant suspend command and suspend machine number 3. Let's see what happens here. So NGINX quickly detects the failure because we set the interval 1 second. And so what's going to happen now is after the 40 seconds, around 40 seconds, the etcd key that we set with TTL equals 40 seconds going to get expired. And we should catch this event. And CoreOS should reschedule the unit from the failed machine onto the healthy one. So let's see if it happens. So you see the unit gets rescheduled. And now let's wait for the expiring event. And as you could see, it happened. So back to the healthy status again. And that's it. That was the demo. And let's go back to slides. And the last slide is, well, thank you for coming. And as Kevin said, we have all the links and with relevant information are available via this page. So go there. And Kevin, back to you, Kevin.
Yeah, did you guys have any questions?
So you said you couldn't use Docker Hub because of NGINX Plus and the license keys?
Yeah, I guess we didn't.
Just for the video.
That's for the video. Yeah, so we didn't use, which one is it? Here, you keep this.
Oh, yeah. This
Anyways, we didn't put that image on the Docker Hub because it has a license key in the image. So when we're pulling it, we're basically building the image locally on the CoreOS machine instead of pulling it from Docker Hub.
So
if that makes sense.
There is NGINX Plus image, not Docker Hub.
No. So we just were lazy to set up private repository and to deploy image there and then set up private repository for our CoreOS cluster. So we just built it and load it up on every machine.
So is there any way to store licenses locally and through a secrets database?
Yeah, I'm sure there's a way. We just didn't get that technical, I guess, with the demo.
It's kind of a barrier.
Yeah, I mean, I'm sure there's a way. I can take that offline and talk to you about how it can be done. But yeah, I'm sure there's a way. I think we just didn't do it from a license perspective. We didn't want to put the license out there.
Any next questions? Yes? So yeah, so Fleet.
Fleet, Mesos, HashiCorp, Nomad, all of these are schedulers, right? So what are like some of the, since we talk about Fleet, let's talk about Fleet. What are some of the, just like things that are different in Fleet as opposed to Kubernetes?
So the Fleet is less sophisticated, I would say. So it's a simple solution, but it's simple and robust solution. But Kubernetes is, it has load balancing, it has service discovery, it has a more sophisticated scheduler, it has concept of replication controllers, services. So Fleet is, let's say, simpler. Well, I guess like somebody from CoreOS can like also put some few cents on that later.
I could actually probably help out a little bit. I'll give you a brief answer to that. Okay, like there's sort of Fleet is a predecessor to the Kubernetes technology. We certainly at CoreOS are moving towards Kubernetes because it is implemented in a very flexible way for large-scale clusters, and a lot of what we see in production-level demands from our customers and our partners. We created Fleet quite a long time ago in the timescales we're talking about in this space. It's a really cool product, as these guys do a fairly good job of bringing out for maybe some simple or more direct service management oriented kinds of things you might schedule on smaller clusters and smaller deployments, or if you're running it for legacy reasons. So we continue to support and develop on Fleet, and in fact, it's been a fairly active code base over even the last maybe few weeks if you look at the GitHub repo for it. We're probably looking towards Kubernetes on larger deployments, but it's completely understandable why they would have approached the problem for this demo and for some of the stuff that they're doing on a back-end way for Fleet, and it matches a lot of the continued use of Fleet we see in our community and in our customer base. Pretty good answer.
I have another question. We could probably take this offline. Michelle Hashimoto sold Nomad as the only optimistic scheduler that's out there. So what would be your answer to that? What are you guys doing with Kubernetes? Because I know CoreOS do a lot of contribute back to Kubernetes a lot.
Yeah, certainly. And I mean, we have a really strong feeling about the folks in the organization back in Kubernetes and the experience that's been brought to bear on that project, and it matches a lot of our experiences and sort of philosophical ideas and how we think things ought to work, and how it's important to componentize things and make them composable and constructible in flexible ways. Does that make sense? I mean, I don't want to speak directly to a controversy with a competing product.
Okay, no, I was wondering if that's like, those are features that might implement Kubernetes quickly, that's some features.
Yeah, I'm sorry to steal your present.
No, don't worry.
If you are sitting by a fellow who can put you in touch with me or people who know even a lot more about it than I do, and I'd be happy to talk to you offline or immediately after this or anything, because they are very interesting questions about sort of Fleet and Kubernetes and that border there and what that's about. So thank you.
I think you had a question. You have one?
He covered it.
Oh, all right, awesome. What else? Anyone else got some questions? That's it. Really?
Well, thank you. Oh, one more thing. So, if you're interested in doing load balancing for Kubernetes, we recently put NGINX ingress controllers on GitHub. So the link is available through this web page. So check it out definitely. Okay, thank you very much.
All right, thanks, guys.